So normally we've been doing this question thing. So what's the question before we get the speakers up? But today we decided to play a game because we're all a little loopy from the end of the semester. So we're going to play this game called Two Truths and a Lie, which was a thing I couldn't say 20 minutes before this beer. So two truths and a lie.
You did it.
So first up, we have Logan. So we asked all our speakers to send us two truths and a lie. And we went, what? So now you guys get to play. So what I'm going to do is I'm going to read out all of those. And then afterwards, we're going to have you vote by applause as to which one is the lie, you guys. There's one lie. We're going to vote for that. We clear? Okay. All right. First up. You have to click a thing.
I do it? Okay.
Oh, my God. I can't see that. Okay. Logan says that she has a picture of her with several tons of cocaine. There are no extra details. She also says that when she graduates UT Austin here on Saturday, she's going to have 4 degrees. Holy crap. She also says that she's been to at least one national park in every state that has one. All right, so I'll think about it for like 10 seconds. All right, so by round of applause, if you think if you think one is the lie, applaud.
Oops.
How about number 2?
I ruined it. Damn it.
How about number 2?
I feel like that's applause for you to 4 degrees.
All right, what about number 3? Is that a lie?
Oh. Not a lot of people like number 3.
Holy crap. Okay, I think they voted for 3. Do you want to let us know?
Number 3 is not true. The truth is I have been to something like 60% of national parks, or 60% of states that have national parks I've been to.
That's still a lot of national parks.
It's a lot.
So wait.
My goal is all of them.
You have a picture of what now?
Well, everybody already saw it. I kind of ruined it, but
yeah,
here it is. That's me, and that is about approximately a little over 1 ton of cocaine behind me. This was 2004. I was an officer in the United States Navy. We deployed to the Eastern Pacific and did drug interdiction, so we stopped boats and searched them for cocaine and seized it when we found it.
Fantastic. So wait, does that mean you're going to have 4 degrees this Saturday?
Yes.
What are those in?
So I have a bachelor's degree in chemistry from Purdue University in 2003.
So
that's
before the cocaine habit.
Before the cocaine. And that's where I received my commission as an officer in the Navy. And then there's a lot of veterans in the audience tonight.
Yeah.
In 2014, I received a master's degree in education.
Well, congratulations to Logan. She's
and
graduating.
On Saturday, I will have a bachelor's in astronomy and physics. So that makes 4.
That's 4. All right, so give it up for our first speaker.
Hi, thank you. I'm so glad to finally be up here on the stage in front of you guys. You may recognize me from the merch table, and if you don't, you need to go over to the merch table because we have a lot of great merchandise. I've been a part of this organization for almost 3 years now, and so I'm really excited to finally be up here and telling you guys about some of the science that is cool science that is happening. So first I have to confess, I'm talking about SETI, Search for Extraterrestrial Intelligence, but this is not my research discipline. I'm actually an exoplaneteer. I study how planets form, particularly planets, giant planets really far from their host star. But this past summer, I got to put on my SETI hat, and I spent the summer doing an internship at the Berkeley SETI Research Center in Berkeley, California. So that's what gives me some sort of qualification to come up before you and talk to you about what SETI is up to. You may remember, if you were here for our 50th show, we did a rapid fire talk where we came up and answered for 1 minute. We answered some of our audience's questions, and I answered the question, what is SETI up to these days? I spent 1 minute answering that question, but that really inspired me to answer that question more fully. So that's why I'm here before you to tell you a little bit about what the SETI research discipline is up to these days. So my talk title is Where All Y'all At, which is a texification of the famous Fermi paradox, which says that given if the given the number of stars that we observe in our galaxy and the number of galaxies that we have, it seems like life should be everywhere. So where is everybody is the Fermi paradox. And the number of civilizations that we could potentially communicate with is frequently parameterized by this famous Drake equation, which lists out numbers of various numbers that we can use to think about what's the likelihood or the number of civilizations we could potentially communicate with. I could give an entire talk on the Drake equation, but that's not what I'm here for. So I'm focusing on this particular parameter, which is the probability that life can start on a previously lifeless world. This is called abiogenesis. And if this probability is actually very high, then there are likely a large number of civilizations we could potentially communicate with. However, astronomer David Kipping recently published on the Cool World's YouTube channel a video where he posited that this probability might actually be very, very low, in which case it's entirely likely that we are alone in the universe. That is a distinct possibility. I highly recommend checking out this video. It's very, very good. But for the purposes of SETI research, we go ahead and say if this probability is very high, and life is everywhere in the universe, how do we go about searching for, how do we go about looking for evidence of these civilizations, technological civilizations in the universe? And that is the nature of SETI research. SETI is a research area. It's a discipline within astronomy. It's not any one particular group, and there are lots of groups who are doing SETI research. I interned this summer with the Berkeley SETI Research Center, which is in Berkeley, University of California, Berkeley. The SETI Institute also does SETI research in San Jose, California. And the Penn State Extraterrestrial Intelligence Center is another big one. They just started a graduate program in SETI, so you can actually get your PhD in SETI research now. And there's many, many more around the world who are engaged in SETI research. And NASA is very involved in SETI research. Last year, they hosted the NASA Techno-Signatures Workshop, in which they produced a paper describing the current state of the discipline and where the path going forward for the future for this research area. Additionally, the private sector is getting involved in SETI research. The Breakthrough Initiatives is a privately funded organization for basically for extending humanity's reach into the universe. It is funded by this gentleman, which is Yuri Milner. He's a Silicon Valley tech billionaire. You may also recognize a few other people in this photo, like you probably recognize this gentleman. This gentleman here is Francis Drake, so from the Drake equation. So the Breakthrough Initiatives are a very high-profile project to extend humanity's reach into the universe. The SETI arm is called Breakthrough Listen, and the Berkeley SETI Research Center has the Breakthrough Listen contract, so they have private funding for their ventures, in addition to working with the University of California, Berkeley. Okay, so SETI is all about searching for techno-signatures. And to describe what a techno-signature is, I'm going to defer to Jill Tarter. You can't talk about SETI without talking about Jill Tarter. And you also can't talk about Jill Tarter without talking about how she is the inspiration for Jodie Foster's character in the movie Contact. And she says, this is a direct quote from her, "If we can find techno-signatures, which is evidence of some technology that modifies its environment in ways that are detectable, then we can infer the existence of some intelligent technologists." It's not possible to envision all the potential techno-signatures, but we can define systematic search strategies for equivalents of our 21st century terrestrial technologies. So she said it better than I ever could, so I wanted to refer to her words. So from this NASA Techno-Signatures workshop, which is where most of what I'm going to tell you about tonight comes from, techno-signatures are thus any sign of technology that we can use to infer the existence of life elsewhere in the universe. Okay, so what do we look for? Excuse me. So the SETI problem is very difficult because of something called the cosmic haystack. As Billy Bob Thornton put it in the asteroid documentary Armageddon, he said, it's a big-ass sky. So that makes searching for the needle in the cosmic haystack a very challenging problem. But Jill Tarter has a response to this as well. She says, one does not need to search all of the world's oceans to find the first evidence of fish. Assuming, again, that there are lots of fish out there in the oceans. Okay, so what do we look for? So the ideal thing to look for SETI searches are things that are timely. So what can we do with the technology we have today, or with a minimal amount of development? It should be cost effective because it is a big ass sky. And it should be used to do other science. This is the first law of SETI searches, which Freeman Dyson posited, which says that any SETI search, any search for alien civilizations, should be planned such that it produces meaningful scientific results even when no aliens are found. That's the first law of SETI searches. And it should not be easily confused for natural sources. Similar to our own tech, it's easier to, so we have one example of the kind of technology that intelligent civilizations produce. Unfortunately, we have only one, but we do have one. So that gives us a good starting point, and it gives us a template to verify potential signals against. Now, as Jill Tarter said before, we can't envision all of the possible ways that an intelligent civilization might modify their environment, but we can use our own as an example as a starting point. Okay, so let's talk about some of the types of SETI searches that are going on right now. Narrowband radio signals is a good thing, is probably the broadest, the most general type of SETI search that's going on currently. This is an example of a signal from the Voyager 1 spacecraft, which we know was developed by an intelligent civilization. And it's very, very, very narrow, this frequency band. Natural sources do not produce signals that are this narrow in radio frequencies. So this is if you can see such a narrow signal, it's probably not natural, it was probably intelligently produced. However, we are awash in narrow radio band signals from our own technology. So RFI, or radio frequency interference, is a major problem for narrowband signal searches. It's probably the most significant technological challenge to disentangle our own narrowband signals from anything that might potentially be an extraterrestrial signal. For example, here is a sample radio spectra with frequency on the y-axis, x-axis, and time on the y-axis. And anywhere you see the bright yellow lines, that's a narrowband radio signal. And this radio spectrum correlates very nicely with the San Francisco Bay Area radio stations. So yes, this was intelligently designed technology, however, it came from us. And this is by far the most significant technological challenge for narrowband radio SETI searches. Currently, the Berkeley SETI Research Center is conducting observing campaigns with the Green Bank Telescope in West Virginia and the Parkes Telescope in Australia. As part of my internship, I actually operated both of these telescopes from my laptop in Berkeley to do the observing for the Berkeley SETI observing campaign. And as we said, it's a big-ass sky, so we have to cast a really wide net. Breakthrough Listen is currently starting up a 1 million star survey with the Meerkat Telescope in South Africa. And my internship project with Berkeley SETI was to do the target selection, or to identify the 1 million stars that we will observe with Meerkat. That was my project. And so I did that. I found 1 million stars for them to observe. Another type of SETI search is called optical SETI. So it turns out, what kind of technology can you look for that falls in the optical and near infrared wavelength range? Lasers are a very effective way of communicating information. So if we were to communicate, if a civilization were to communicate through lasers, we could look for laser lines in our spectrum. This paper came out last year, in which they identified the magic wavelengths in optical range for most efficient communication of information through laser lines. And so this defines a starting point to look for potential signals in optical wavelengths. The Berkeley SETI Research Center is currently conducting a campaign with the Automated Planet Finder in California, which its primary job is to search for planets using optical spectra. But at the same time, the Berkeley SETI folks can look for laser lines in those spectrum. And this is the APF mirror, and there's me. The Penn State folks are doing a similar campaign with the NUID spectrograph currently as well. Okay, so there are some more out there ideas. Perhaps you have heard of Dyson sphere, in which a civilization constructs a structure that lets them harness the power from their own star to power their civilization. And if a civilization were constructing a Dyson sphere, we could observe the effect on the flux from the star as it would appear to dim over time. This may sound familiar if you've been following astronomy, because this was posited as an explanation for the dimming of Boyagin's star. Unfortunately, sorry to spoil, it is not aliens. It is currently believed that the dimming is explained by dust or comets, but definitely not aliens, sorry to say. You may have heard of the Oumuamua asteroid, which is an object the first known object that originated from beyond our solar system, so it is not gravitationally bound to our star. And the Berkeley SETI folks did observe it with their radio campaign, and also, sorry to say, it is not aliens, but that idea was out there for a while. And this paper came out last month, in which they discussed how to look for glints from mirror surfaces. So whenever you look up in the sky and you see a satellite passing over, what you're seeing is the reflection of our sun off of their mirrored surface. So if a technological civilization in another solar system created mirrored surface satellites, what would that look like to us, and how would we go about finding it? This paper just came out last month, so that's another idea. But above all, any potential signal must be repeated, and it must be independently verified by multiple groups. Or to quote the Berkeley SETI researchers, we are the most skeptical people of all, despite what you might see in the headlines. No one is going to try harder to disprove a potential signal as having extraterrestrial origin than the SETI researchers. And if you remember the first law of SETI searches, any search must produce interesting science, even when you don't find any aliens. SETI searches produce tons and tons and tons of radio data, which can be used to do really cool science. For example, fast radio bursts are very mysterious objects that give off very rapid, very intense bursts of radio signal. It's really not understood what they are or how they're doing this. And so they're a very good target for the data that the SETI groups produce. For example, this fast radio burst 121102 is the one that has been repeated the most, and so has been studied the most. And the Berkeley SETI folks just created a machine learning algorithm to characterize this fast radio burst, to try to figure out what these things are, because it's very much unknown. Pulsar timing is also a good use for the data. So pulsars are neutron stars that are rapidly rotating and give off a pulsing signal in the radio wavelengths. And some of them rotate on millisecond timescales, so really, really fast. And they're very, very, very precise. And we can measure their timing very, very precisely. Just last year, some folks put out a paper where they had used the very precise millisecond pulsar timing as a test of general relativity. This is another good use of the SETI data. And I just want to end by saying that you can get involved with SETI as well. The SETI at Home project has been around since the late 90s. I had it on my computer in high school in like 1997, and it's still going, and you can get involved too. So the SETI searches produce tons and tons and tons of radio data. And so what SETI at Home does is, when you're not using your computer, they take over your computer and use your processing resources to help process their data. So you can get involved in helping the SETI project go forward as well. So in conclusion, we might be alone, we might not. We can be smart about how we use resources to look for evidence of extraterrestrial intelligence, and we can do a bunch of cool science along the way. Thanks.
Thank you, eccentric orbiter, Logan Pearce. All right, so we have some time for a little bit of Q&A, the way this is working.
Please remember, this is not my research discipline, so I'm going to try my best to answer your question.
You are more than capable of answering these questions. If you have a question, raise your hand. We will call on you. You will ask the question. Hopefully one of us will remember to repeat the question, yes. And then Logan will give us an answer. All right.
I see a hand here.
All right, let's start right here.
So the question was, how did I choose the 1 million stars for us to observe with Meerkat? So I was really hoping someone would ask that question. So the cool thing about us... Yeah, I came prepared with the slide. So the cool thing about the way radio telescopes work is you can actually form multiple what's called beams, which is where the telescope is looking. So the way the Meerkat observations will work is the SETI folks actually cannot drive the telescope. Their observations are entirely commensal. So commensal means while somebody else is looking at a science target, like for example, this is a illustration of a pulsar. So while one science team is looking at a pulsar, the SETI folks can at the same time look at any other stars that fall within that beam. So my job was to try to anticipate where the beams were going to be pointed in the sky, since we can't choose that location. So I did my best to try to figure out who will be using the telescope and where they will be looking. And then I used the Gaia catalog, which is a very precise astrometric catalog from the Gaia satellite, to figure out what stars will fall within the beam while the science program is looking at the main science target.
We have a Twitter question.
Cool.
And this is a really good question. So if you are the person that asked this question, prove it at intermission. We'll give you a free keychain for this.
Nice.
Elava Sam, sorry if I'm mispronouncing it. Would a telescope placed on the far side of the moon filter out radio chatter from the Earth? Is that a feasible option to discover radio waves from alien sources?
Oh man, that's such a good question. I don't know a whole lot about how radio observing works. In fact, this was dipping my toes into it. But people are telling me the answer is yes. Sam says yes. Some of the space cadets might do a better job of answering the question than I am.
Yeah, pesky radio sources that can be blocked by the moon.
Yes, of course.
Would be very nice. Yeah, the Earth has a lot of noise that it emits.
Yes.
All right, how about a question over there at the end?
Question over there.
Yeah, do you have an opinion as to the resolution of the Fermi paradox? Just your opinion.
Ooh, do I have an opinion as to a resolution of the Fermi paradox? So the Fermi paradox was given the amount of stars that we can see in our own galaxy and the amount of galaxies that we can see. We also now know that each star has at least one planet. Surely there's other life out there, and why haven't we communicated with any other civilizations yet? That was the Fermi paradox. Well, it all hinges really on that, on those parameters in that Drake equation, including the fact is that we just don't have ability to put any actual numbers in that Drake equation yet. We're working towards it, but we really have no idea to the value of anything in the Drake equation as of yet. So it really all hinges on all of those parameters. But scientists are working on those parameters.
If you want a dark view of why the Fermi paradox seems to be holding the case, some people have thought maybe intelligent civilizations are self-destructive.
Oh yeah, there's that one. That's a term in there.
Which is kind of dark to think about. A more reasonable resolution might be just, we have to remember, if I can borrow a phrase from California, is that the universe is hella big.
Yeah.
And that it's very hard to travel and communicate. Even if you're traveling at the speed of light, it can be very, very challenging to get from point A to point B.
Right. Although I do like the line, I've always really liked the line from that movie Contact. The child version of Jodie Foster's character, her dad tells her, I don't know if there's life out there, but if there's not, it's an awful waste of space.
Agreed. All right, maybe one more question before we move on.
Oh, right here.
Oh, yes.
Oh, right there.
Oh, sorry.
That's okay.
You mentioned the SETI at Home project.
Yes.
Are there any other projects that you could help with at home? Something from Project Breakthrough, for example, that you could help with from your computer?
So the question was, aside from SETI at Home, is there anything else you can do with the breakthrough initiatives to help out with the citizen science endeavor? The breakthrough initiatives, to my knowledge, do not have anything besides SETI at Home. It is run through the Breakthrough Listen team, so they do manage it. I don't know the answer. It's a great question. There's plenty of citizen science projects. The Zooniverse offers lots of ways for lots of different projects that anyone can join, such as characterizing galaxies or looking for transiting planets. There's a lot of citizen science projects through the Zooniverse. I don't know of any that are SETI specific. Good question, thank you.
And my last question for you, what is next for you, Logan Pearce?
What is next is I am moving to Tucson to begin a PhD program at Steward Observatory in the University of Arizona.
Another round of applause for Logan Pearce.